All right. So, welcome to the new class on logistic regression. So, in previous few videos, we had talked about what is linear regression and how is it useful in solving the regression problems. Now, in this tutorial, we are going to learn about what is logistic regression. So, as the name suggests, it's a regression, but it is used to solve the classification problems. The logistic regression that is used to solve the classification problems. So, what do we understand by classification problems is that we kind of solve problems which are dealing with its discrete classes, right? For example, yes or no type of questions, or maybe if a person has cancer or not. So we are basically dividing the data into certain classes. So that is what we call as the classification problem. So logistic regression is actually used to solve that kind of problems. Now, let's take a very simple example that you have given a GRE score, right? And then whether based on your GRE score, will you get an admission in a university or not? So what I've done is that I have represented the get admission as index 1. And if you don't get admission, that is represented by index 0. So the question lies is that if you get a certain amount of GRE score, what will be your target level? So means to say that whether you will get an admission or not. So that is the kind of problem that logistic regression solves. So let's look forward to this. Now, I have generated this synthetic data set, right? So we have some few GRE scores, and based on that, there are certain labels of admissions, right? Now, one represents that the student will get admission, and zero will represent that student does not get admission. So as you can see, there are a certain number of GRE scores, and based on that, I have corresponding labels. And what I've done is that I have simply generated a scatter plot out of these. So these red lines, they are representing the students which do not get admission and the blue lines which are getting the admission. Now, what if we try to solve this using linear regression? So in my last video, I talked about linear regression, which is actually used to solve this regression problem. So regression means finding a continuous value, right? For example, price of a houses or maybe price of stocks and so on. But can we use this to solve this classification problem on whether a student will get admission or not based on his GRE score? So as you know that the equation of the linear regression line, what we talked in our previous lecture, the simple equation is y equal to mx plus c. So this is the best fit line that you get, right? This is the equation of the line y equal to mx plus c. Now you can see that we are fitting this through these two of the data points. So this is representing the students which are not getting admitted, and the blue points which are representing that students are getting admitted. So you can see a pretty line which is very poor, right? Because we expect that the linear regression should pass through most of the data points, but you can see that it is a very poor line. So we say that linear regression is very poor in actually solving these classification problems, right? So as I've written here that linear regression outputs these continuous values, but classification requires the discrete values, right? For example, this could be a class 1, this could be class 2, this could be class 3, right? Now our test data would lie certain in class 1, class 2, or class 3 based on the particular feature analysis that we do. Now what we have done is that we have simply fitted this regression line for the classification, and you can see how poor line is this. So in conclusion, you can say that linear regression does not work well for classification problems. So we need something called as logistic regression, right? Now, what if we could squash the predicted value from linear regression between 0 to 1, right? So what I'm trying to do is that I'm converting the continuous values between 0 and 1, right? So we are going to see how does it works exactly. Now, what we are going to do is that the output which we get from linear regression, that is, this equation is very similar to y equal to mx plus c, right? Now, this is representing your intercept, y-intercept, and this is a slope. So y equal to mx plus c, I have simply written this as y equal to a plus bx, which is kind of same. And what then we are doing is that we are passing this to a sigmoid function, and then we are getting the output is h of x. So any such output we are passing through sigmoid function, and then we get an output hx, and that is what logistic regression actually does. It actually combines the output of the logistic regression, passes through an activation function that is called a sigmoid function in this, and then we get a particular output. So let's see how does this exactly work in a much more simpler way. Now let's say that This is the graph of my sigmoid function, right? You can see it is a S-shaped curve. Any such curve recognized by S-shaped curve, that is called as a sigmoid function, and it is generalized by this equation 1 over 1 plus e power minus z, right? So this is the fundamental equation of this particular line. Now what I'm going to do is, you can see my values are getting squashed between 0 to 1, right? And what if I keep zero point 0.5 as my threshold, right? I'm keeping the zero point 0.5 as my threshold, right? In this, I'm keeping zero point 0.5 as my threshold. Now, what I'm going to do is that I'm going to simply say that anything which is lying above zero point 0.5 is 1, anything lying below zero point 0.5 is 0, right? Anything lying above or at zero point 0.5, that is 1, and anything lying strictly below this zero point 0.5 is 0. So what I will say that if there is any such new data, and if it is lying above zero point 0.5, then I'd say that that particular student is getting admitted, right? Meaning this is getting label 1. Now, if any student is lying below zero point 0.5, I will say that the student does not get admitted. So that is labeled as 0.0. So this is simply how the logistic regression works. So you pass on the values through a sigmoid function, right? You set a value of zero point 0.5 as a threshold. Now, anything which is on the threshold or above the threshold, that can be put onto one category, and anything below that can be put off to other category. So you can see that g of z actually strictly belongs to 0 and 1. So that is what the sigmoid function actually does. I hope you got the idea on that. So this is the input to the sigmoid function. That is b naught plus beta 1x, and then we are passing this through a sigmoid function, that is 1 over 1 plus e power minus z, and since this is the input to that, so we are again expanding the equation like this. Now what we are going to do is that we require some probability, right? So if anyone has scored a GRE score of 315, then it is giving us 0.77, that is the probability. So it has 77% chance of admission and 23% chance of rejection. So this actually lies above zero point 0.5 in our case. As I told you before, this is 1 and this is 0, and 0.77 is lying above zero point 0.5. So obviously this man is getting admitted. So it is going to give us the label 1. So that is the fundamentals of how this logistic regression works. So you can see that h of x, which is the output, this is giving you the probability of 1, and not being admitted is 1 minus h of x, right? So let's say that if I have an admission chance is 80%, then what is chance of not being admitted? So it's simply 1 minus uh, 0 0.8, right? So it's going to give me 0 0.2. So 20% chance of not being admitted. So that is what this equation simply complies. So just a brief review, right? We are going to pass anything to a sigmoid function, right? We are going to set a value of 0 0.5. This is 0, this is 1. Anything which is lying above 0 0.5 should be considered 1. Anything lying below 0 0.5 should be considered 0. So that is simply how the logistic regression actually works. So I already told you we use a threshold value, right? For in our case 0 0.5, and if it is greater than or equal to 0 0.5, we predict y equal to 1, less than 0.5, y equal to 0. So you can see that there are particular data set which I already showed you previously. So there are a few of the GRE scores, CGPA and admission to that. Now anything, if you can do a testing to this, suppose this point, then what you're going to simply do is pass this through a particular sigmoid function and test it whether it is above threshold or below threshold to know whether is it being admitted or not being admitted. So that is how simple it works, right? Next thing before I show you the implementation part of this is the decision boundary. So decision boundary is actually the hypersurface that separates the region where y equal to 0 and y equal to 1. So it is simply a line like this, which is separating two classes of data. So this red region is where your students are not getting admitted, and the blue region is where students are getting admitted. So that is basically what your decision boundary means. Okay, so we now finally move on to the implementation of the logistic regression, right? These are the things that which I've already told you, that what is classification and all. Now what I'm going to do is I'm simply going to import my pandas and my numpy, and then I'm going to import my matplotlib, to in order to visualize something, visualize my data set, then I'm going to create a synthetic data set. So if you look at the data set, we have created a GRE score and admission, right? So how I will create it, I am using the sklearn make classification module for that. So if you go and then simply look at the documentation of that, of the scikit-learn, you could see what parameters we have actually used. So in our case, we have used 20 number of samples and number of features is 1. So features in this case is our GRE score. We haven't repeated any such thing, right? Number of redundant information is 0, shift by 30, scale by 10, number of classes is 2, which is getting admitted, that is 1, not getting admitted, that is 0. These are the number of clusters per class that you could go and just simply find in this. So you can just find in this documentation. So it is the number of clusters what we form per class, which again will come in the future lectures of clustering, right? And this is the number of informative features. This is the class separation, which determines the size of the hypercube, and then random state for actually complying with that states of reproducing same time the random numbers. Then we have used the data frame. So this gives you the first row, and then we have converted. So this is actually giving you the scores, right? And then we have actually converted that to an integer with a ceiling value, and then we have concatenated that with the outcomes, that is 0 and 1. So this is going to basically combine both of these, concatenate. And if you look at the data set, I've just simply assigned the GRE score and admission columns to that. So if you simply look at the data set, then you could find a GRE score and admission in this. Now, once we are done doing this, we are just going to visualize, which I showed you in the slide also. So this is what it looks like, GRE score and admission and so on. So we tried passing the linear regression. So from sklearn.linear model, we are simply importing the linear regression module and fitting onto X and Y. So if you haven't watched my previous video, you can go and check out how can we implement the linear regression module onto that. Simply we can call from linear regression and then fit onto that. And so this is what your linear regression line looks like. So if you compute the R squared for this, it's going to be very poor. So we have passed this through logistic regression. We are passing the output of the linear regression through the sigmoid function. So what I've done is I have created a sigmoid graph like this. So for that, I've used the line space function. So it's going to evenly create 1,000 number of partitions between -10 and 10. And this is going to give you the sigma value, which I've written here, the equation of the sigmoid function. And if you plot it like this, we are going to get a sigmoid curve. So what I told previously was we are setting a 0.5 threshold, and anything above 0.5, you know that, right? I've talked many times. So this is what the exactly the logistic regression model looks like. So I will again simply call that from my sklearn. I will import the logistic regression from there, and from there I've called it the model and fit it onto X and Y. So this is your model, and then what you can simply then do is interpret the output of logistic regression. Now for that, I have predicted the score of Jacob, that is 304. So it will give me the corresponding labels to that. So one is what Jacob is getting admitted onto the university, right? And Lacey, which has 299, so it is obviously less than threshold. So that's why she is getting a label of 0. So that is how we can simply go and then check out how we can perform the logistic regression in code.